better with the mic on. Good morning, everyone. Let's see. Okay. How's everyone? Good? I'm doing good. All right, so we're doing today, we are working on the Pythagorean Triplet exercise on exercism.io. So what is that about? Introduction. A Pythagorean triplet is a set of three natural numbers, a, b, c, for which a raised to the power of 2 plus b raised to the power of 2 equals c to the power of 2. And such that a is smaller than b and b is smaller than c. For example, 3 to the 2, 4 to the 2 equals 9 plus 16 equals 25, which is the same as 5 to the 2. Okay. Given an input integer n, find all Pythagorean triplets for which a plus b plus c equals n. Ooh. For example, with n equals 1000, there is exactly one Pythagorean triplet for which a plus b plus c equals 1000. Oh, that's interesting. Okay. Now, there is probably some math formula that I can use. All right, let's start by downloading this exercise to my machine. Okay. Oops. TypeScript and Py something. Yep, there you go. Add Pythagorean triplet exercise. Here you go. Okay. Let's take a look at the test. So, oh yeah, I need to install dependencies. Man, I really should set something up where I don't have to download the do an npm install in each of these folders every time, because it's starting. I wonder I wonder how much let's take a look. No, where is it? Exorcism, no. Where would that be? Here. Yeah. Yeah. Still going. This thing is huge. I'm gonna have to write a script to go into each of these folders and like do an npm uninstall or something at some point. So we can just keep the source code, like the source code for the exercise. Wow, 2 gigs. Okay. Well. All right, so we're expecting a class that we're going to instantiate. So we need an instance method called sum and a constructor that takes 3 numbers. We also want a product. Interesting. So they are just sort that map triplet. Oh, we're also expected to provide a static method called where. Interesting. Triplets dot where 10. Can make triplets up to 10. So this is probably some kind of a static constructor. Well, not constructor, but static method that returns a product triplets dot sort an array, I guess. An array. Interesting. Triplet dot product. No, not an array. An array. Okay, where? Well, whatever. One thing at a time. So let's start by just creating our class, which we'll call triplet, but it needs to be default. Export. So export default class triplet. Okay. So that's good. Now it's saying, hey, the constructor, what's going on? All right, we'll give it a constructor. That takes in, how would we call that? There is a term for that, like, that is not my strong suit. Geometry and the math that goes with it has never been my strong suit. It's interesting though, but I don't know, just never paid much attention to that part in class and never had to really use it in real life all that much. So, right, isn't it like the cosine and the sine and all that stuff that's related to triangles, and Pythagoreans probably related to that too. So let's just what do you call, well, let's just go Pythagorean triplet. Yeah, that's what I meant. Sure. Triple consists of 3 positive integers, A, B, and C. Oh, Wikipedia article. Look at that. They're probably going to tell us what each part is called. Otherwise, we're just going to call them A, B, and C. All right, looks like that's what we're going to do. We're just going to call them A, B, and C of type number, B of type number, and C of type number. We're going to do anything with those? Probably. What? I don't know yet. Wait, hold on. So this is just telling us what it is. 3 plus 4 plus 5 is 12. Yeah. Yeah, what? Why are we? Wait, what? Okay, hold on. Let's get this guy here back on the screen. Why do we need to get the sum of these? Triplet is a set of national for which such that, for example, given an input integer n, find out, yeah, triplets for which a plus b plus c is equal to n. Ah, okay. plus b plus c is equal to n. I got my canoe and my gig. Gonna get me some frog legs. Nice, Steve. Awesome. Are you any good with that stuff? I'm doing Pythagorean triplet. It is not my strong suit. Everything to do with like trigonometry and triangles and sine and cosine and all that stuff. I've never been much involved in that side of maths. You just tuned in. Cool. Well, I just started. So you didn't miss anything. But essentially what we're doing is we're asked to find a Pythagorean triplet, which is basically a set of three natural, oh cool, electrical engineering. So yeah, so you may be familiar with this. I don't know. So a to the 2, b to the 2, a to the 2 plus b to the 2 equals c to the 2. That we're trying to find numbers like that. But here's what I'm not sure. Given an input integer n, find all Pythagorean triplets for which a plus b plus c is equal to n. Oh, okay. For example, with n 1000, there is exactly one Pythagorean triplet for which a plus b plus c is equal to 1000. Interesting. Okay. A squared plus b squared equals c squared. That's right. That would be a faster way to say it. In French, we say au carré, which means squared. Or to the square, I guess. So a squared plus b squared equals c squared. That's correct. That is correct. In Thai, they say, oh wait, I have no idea. Yeah, I don't either. So we're going to need to store this for some reason. So let's do that. And oh, let's change that. No parameter properties. Yes, please. I want me some parameter properties. Thank you. There's declare, but okay, we're gonna take care of that in a second. Now we need a instance method called sum. So let's give it that. Doesn't take anything. It returns a number. Cool. Return a plus b plus c. Right. C'est moi. Okay. That should be sufficient for this test case. Oh. It won't compile because of these. So let's do that. So it passed, good. Next thing, let's move this down here. Calculate the product. I think the product is a multiplication. If I remember my English math terminology correctly. Well, actually, let's confirm that. 3 times 4. Wait, hold on. Product. Yeah, I think that's what it is. So 3 times 4 is 12. Times 5, yeah. Okay. Good. Good, good, good. Return this dot A times this dot B times this dot C. Yay. Let's try our test. And we're good. No, we're not good. We're not good because I didn't unskip the test, but we'll still be good. There we go. Okay, next test. So now we need is Pythagorean. Is Pythagorean to be true? Is Pythagorean to be, oops. I don't know why Prettier does that when you paste stuff sometimes. Okay. How do I determine that again? Let's see. It's when a to the square plus b to the square is equal to c to the square. Okay, so that's easy enough to check. If, actually I just do return this dot a squared, oops, squared plus this dot b squared is equal to this dot c squared. Oh, return true. I am so silly. Okay, there you go. So that should work. Do I need to wrap this in a, no I don't. I don't think so. In a parentheses, it should work. Unskip that. And it's good. All right. Next one. Can recognize a non-Pythagorean triplet. Okay, just need to test my implementation in a different way. It works, good. Next one. Ugh. Oh yeah, okay. Now I don't know what this is all about. I need so that's a static method, right? I'm not instantiating anything, yeah. A static method that takes a number. So let's just do it. I don't know if there's a best practice in TypeScript for let's put it at the top. While it takes in a number, which will be num, I guess. And what does it return? That's the thing, right? It should be returning products, triplets, dot sort. So dot sort. So this needs to return an array of something. And it maps okay, so it's an array we're returning an array of triplets. Okay. So not while, what was it? Where. Okay, where. Wrong W word. Where is going to return an array of triplets. Okay. Oh, and this is where I need to give it an input, okay, integer n. Find all Pythagorean triplets for which a plus b plus c is equal to n. Oh, yeah, that's going to be interesting. I have no idea, but this might help. Formulas for generating Pythagorean triples. Haha. I like it. Let's go in. Let's go look at that. Euclid's Pythagoras and Plato's formulas. What? They solved that stuff like thousands of years ago. The method below appear in various sources, often without attribution as to their origin. And of course, it's all in crazy math notation. Someone ought to, like a programmer ought to make a website that aggregates all of that math stuff that you need to use as a programmer once in a while. You know, like just like often, not often enough that you actually retain the information. You have to look it up every time and not have to deal with that stuff, you know? Like just give it to me in pseudocode, man. Like what the heck is this? Like Q1 in brackets with a dot under it. I need to go look like at it, read for 3 hours to figure out how to read this formula, which is probably not even all that complicated. But anyways, enough for the rant. Leonardo of Pisa. Who's that? Anyways, describe this method for generating primitive triples using the sequence of consecutive odd integers, and the fact that the sum of first n terms of this sequence is n squared if k is the nth number of what? Of whole and fractional numbers. I like this one even less. Dixon's method. Okay, this looks simple. Attributes himself the following method for generating positive. To find integer solutions to x. Find positive integers r, s, and t such that r squared equals 2st is a perfect square. Then x equal r plus s. Y equals r plus t. Z equals... From this we see that r is an even integer and that s and t are factors of r squared divided by 2, or r squared over 2. All Pythagorean triples may be found by this method when s and t are coprime. What is that? Like, I hear coprime and I'm thinking insurance for some reason. Or mortgages. The triple will be primitive. Okay. Generalized Fibonacci sequence for Fibonacci numbers starting with f1 equals 0 and f2 equals 1, and with each succeeding Fibonacci number being the sum of the preceding two, one can generate a sequence of Pythagorean triples starting from a3 equals f. Oh, using quadratic equations. I remember not liking quadratic equations in school. By use of matrices and linear transformations, height, excess, and enumeration theorem. Wade and yeah, okay. There's probably a programmer out there that wrote an article or something about it. If not, I might have to do it. So formulas are just, how about generating pi? See, the thing is, if I wasn't live streaming, I might take my time with this a little bit and read up on, but it makes for a really boring live stream. So I need to find a solution. Generating Pythagorean triple in JavaScript, because everything's done in JavaScript. Elixir, Python, and JavaScript. That sounds like what we're looking for. Let's take a look. Ooh, and that's a nice medium article. A squared plus b squared equals c. Yes. So which method is he using here? We create a function called Pythagorean Triplet that receives one argument n, which is the number that we're going to calculate. If n is equal to 12, this function should return all the possible Pythagorean triplets where a, b are less than 12. So is it going to return a... Oh, he's just logging to the console. But that's no big deal. We can... if n is equal to, in this case, I will use a for nested loop. Ugh. For the purpose of this exercise, we're going to find the result using a brute force algorithm. Yes, I could have done that. I'm looking for one where you use the math, dude. All right, let's put that aside for now. Let's look at this one. Another medium article. What is a Pythagorean? Yep, I know what it is. What's the best approach? Let's see. With many of these types of problems, there is always the brute force approach. I know. Looking for something else. Since we're still working with relatively small numbers, in this case, a brute force approach would still work. But in cases where the numbers and permutations of numbers are in the millions, which is probably not our case, but, you know, brute force doesn't work as well. That being said, sometimes I have a difficulty coming up with solutions other than a simple brute force method. Yeah, amen. For any programmers who didn't come from a strong mathematics background, yes, I'm sure you can relate, yes. Nevertheless, let's move forward. Okay, Python, let's skip that. JavaScript, good. In JavaScript, I'll do basically the same thing. However, in this one, I'll use the mathpal method to convert the values into their square before checking them. This is one difference between blah, blah, blah. Okay, which method are you using, though? I'll start off using 3 variables which contain a list of numbers. Even though I'm going to tackle this problem by using... Oh, man, another brute force one. And he's using like a triple layered for loop inside of another... No, that's another... Okay, whatever. So if I'm going to go brute force, I'll take this guy. Let's try another one. Geeks for geeks. All right. Geek for geeks. No, geeks for geeks. Okay. There's many geeks for many. It's a many-to-many relationship. Okay. Yes. No. Nope. Nope. Simple solution is to generate these triplets smaller than given limit using 3 nested loop. No. No. Don't want that. An efficient solution can print all triplets in OK. OK. What is K? I'm used to seeing N or 1 or sometimes C. What is OK? O. No. O. K complexity versus O N. So to take linear time, if it's time, time complexity. Don't want to read for 3 hours. Just show me the OK. I don't see the OK. Why? Google. Oh. Okay, show it to me on the screen. Where? Where is it? Where is it? What? What? I don't see anything highlighted. Oh! What is it, like in white text somewhere or something? Let K be, okay, so it's the constant thing. All right, cool. Okay. Yeah, I'm looking for that. The idea is to use a square sum relation of Pythagorean triplet. Addition of squares of A and B is equal to square of C. We can work, we can write these numbers in terms of M and N such that, we can see that so instead of iterating for A, B, and C, we can iterate for M and N and can generate these triplets. Interesting. That's, I think, our solution here. Maybe not quite. I'm looking for one that uses one of these formulas. Is that one of these formulas? I don't think it is. But one where I'm not having to use nested for loops would be awesome. Let's keep looking. Rosetta code. So yeah. Yes, yes. That. Oh. Whoa. Implementations in like alien languages and stuff. They must have JavaScript or even better TypeScript maybe? No. I would have been asking for too much. ES6, yes please. Exhaustive search of a full Cartesian product, not scalable. Well, then. What about this? Brute force permit. Okay, everybody's using brute force. Is it the only way to do this? Ooh, stack O. This is a solution. It is, and it's using only one for loop, isn't it? But that might be because we're being... okay. Maybe I have to be more specific. Give me... Let's see, I'm curious to... Somebody probably did this, but most efficient algorithm to generate Pythagorean triples. What is the best way? Oh boy, that's going to be interesting. On Stack Overflow. Let the fighting begin. Found that this algorithm was pretty easy to implement in Python and works pretty fast. Pretty, yeah. What's he doing here? A and B, C was 1, 2, 3, while C is smaller than N. A 2 plus A, C my square root. You have no idea what is going on here. And there's no explanation. If you restrict M and M to coprime numbers and force M minus N to be odd, you will uniquely generate all the primitive Pythagorean triples. From this point on, you should be able to multiply these unique triples by factors of D to uniquely generate all triples. Ha, no code example. Cool. Cool. All right. Well, looks like we're gonna go with this dude, because I'm done reading about that stuff. Well, let's see. Don't need this, already have that. And I don't actually want to log it. I want to store it and return it at the end. So let's call this triplets. Triplets of type array of triplets. Right? Yes. That's what we're looking for. Thank you. Initialize it to an empty array. Var. Okay, let's just call this N. It'll be easier. There you go. And I need to change C. Where does he get the C from? Doesn't initialize C anywhere, does he? This guy just goes and does C. All right. No vars, no lets, no nothing. When was this written? 2017. Yeah, 6, man. What the heck? All right, whatever. Guess I have to do some work. So first, we will do this. And then we will do that. Oh, I can use a const here. Is that what I'm... Yes. Okay. Then I'll just push this to triplets. Yep. Okay. Argument of type number is not assignable to parameter of type triplet. Is not? Yes, that's true. I have to instantiate it. Yes. I have heard your complaint, TypeScript. So that's done. Then I just return this thing. Triplet. Now I really wish I was, actually understanding what was going on there. Am I missing something? There's a bracket missing somewhere. There's my for loop here. Looks good. My for loop here looks good. Got my if statement. I've got one too many. This needs to be inside of this here. Is this right? I think it is. just need to wait a minute. Oh my God, that's cool. Then why is this nested? It doesn't have to be. There we go. There we go. Okay. Let A, if A is smaller than n minus 1, A plus plus, well not if, but I mean while A is smaller than n minus 1, for let B, basically B is smaller than n, B plus plus, math square root of A times A plus B times B. If C is divisible by 1, I see what we're doing. Okay, this is the, well, I guess it is brute force, but I think it's the algorithm described here, isn't it? Or maybe not. No, we're not doing the fit. We're doing every number, but it's the same principle, I think. Anyway, let's try it and see what happens. Well. Saved by the Google. Unnecessary semicolons. Yes, I know. But Prettier likes them, so. Can probably remove this, remove that. Undefined. Triplet where 2011. What is that? Oh, damn. Okay. Can filter on some. Oh, wow. Well. Looks like we're not gonna get away with it so easily. Okay, how could we? Well, first we need to accept at least 3 arguments. Can make triplets 11 through 20. Can filter on some. I don't get what is supposed to happen here. Why is there an undefined in the middle? I am confused. Huh. All right, let's try to fix this one first. Can make triplets 1 through 20. And 20 is first. Can filter on some. It's not clear at all on what's going on, and there's nothing at all in the instructions about all this. It just says given an input integer n. What the heck is this? Right? It doesn't say given a range. is not one of their best. Described projecteuler.net. Special Pythagorean triplet. There's exactly blah, blah, blah. Okay. And nothing else. Cool. Well, the thing is, I really don't know what they're expecting me to do. Well, okay, for this one, it seems pretty obvious. But for this one? So they want a range here. Okay. So I think I can do that. Actually, let's see if we can get lucky and get someone on exorcism. Hey guys, working through what's it called again? Pythagorean triplets, or just triplet. On what the last test case expects from me. Should I put a code snippet? I might as well. I guess I don't need to do that. I'm just copy pasting stuff. First message. Okay, never mind. What am I? Okay, here. This. Okay. Create snippet. Nothing about this in the instructions. Is that what they call this? Instruction? The introduction. Let's put it introduction. In the introduction. So if we're lucky, we might get an answer quickly. Otherwise, we're on our own. For now, let's try to get the range thing going. So we're taking our n here. So what we need to do basically is start our a, instead of starting at 1, is start it at our first of the range. But now this one is higher, this one's lower. So we're just going to need to, okay, here's what we're going to do. We're going to take all arguments, and they're going to be number array. And then we're going to sort it. So args.sort. Hopefully by default it's from smaller to bigger, I think. And then we're going to take, this is going to become args. Does that return a new one? No, it's in place, right? Yeah, args, the first one, and then this will be args, the last one. So args dot length minus, well, actually, there you go, -1. And then, and then this here, let b equals a. It's all good. Don't need to worry about that. b is smaller than n, which is our args dot length. Let's see if that works. Did we break everything? It looks like we did. Okay, let's just 1 through 11, even up to 10. Expected value, I'm getting an empty array. And I'm getting an empty array. Why exactly? Because, yes, I need to have this be or 1. Right? Not a bitwise operation. Okay, there we go. Still didn't work. Cool, 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 cool. Yep, I like that. Okay, okay. I believe it's time to bring out our little friend Quokka. Quokka. And let's just replicate this stuff here. Like that. Okay. Why don't you? Yeah, empty array. That's what I'm being told is going on. Why is that though? Let's see. What do we have here? 11 and 20. Cool. Actually, I want to know why this one doesn't work first. Start with this. Okay. So yeah, I've got an array of 10. So then logically, a dot 0, ends up being 10. So instead what I need is alright, I need some sort of if statement, I guess. If, or could I just make this a ternary and make this really ugly? Yep, I could probably do that. Dot length is smaller than 2. Then just give me 1. Otherwise, args dot length. No. Like this, okay, the args dot 0 0. Okay. If args dot length is smaller than 2, then go with 1. Otherwise, go with args dot 0. And a if a until a is smaller than args dot length. Args dot length will be 1 minus 1. As long as a is smaller than 0, that doesn't make sense. Ah, this sucks. I can't just remove this, right? That wouldn't work. No, I wouldn't. This needs to be well, actually, args dot length minus 1. Yeah, that's fine. That shouldn't be a problem. And then r equal args dot length is smaller than 2. If that's the case, then just return 1. No, that's not true. Yeah, it's true. If it's smaller than 2, it means it's 1. There's 1. Otherwise, you return this. Why doesn't this work? It should work. Huh. Alright, let's take a look and see what A is throughout the looping process. Hello. Oh yeah, okay. I wonder if I could just do, I think I can do this. No? That would have been nice. What if I put it here? How about now? Nope. Okay. Fine. So let's just use good old console log. Calls to console log are not allowed. What? There. Ugh. Ha! Except now it's not picking it up. Wait. How? A is not defined. Yeah. And then if I put it in here, just nothing happens. Wait a minute. This just doesn't run. Okay. 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 So what's the problem here? A is args at length. Start at 1. Then args at, if A is smaller than args dot length, args dot length minus 1. Yes. Dot length minus 1. Okay. There we go. Now this is probably working. see. Yay. Okay. And if I try this one here, still don't know exactly what they mean here, but if I try to run it, TypeScript's gonna say, "Oh, you can't pass in undefined. What the heck, man?" Fine. Okay. Let's see what we can do. We're going to. Seems kind of silly. I just. Whatever. Let's do number or undefined. Rest parameter must be an array of. Oh yeah, I need to do this like that. Fine. And this guy's complaining. Oh, what if it's undefined? Okay, then let's filter this thing. Get rid of. How does this work again? Function that exists up to 3, the filter method calls and returns the elements of an array that meet the conditions specified in a callback. Okay. So that's pretty easy. Don't be undefined. Well, actually, there you go. Oh no, that's not that simple. It's just, it's got to return the Boolean, or how does it work again? It's got to function that accepts up to 3 arguments. The filter method calls blah 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 blah. Reach rakes, but yeah, I need more. I haven't used filter in a while. So back to the docs. Okay, don't need you guys anymore. MDN array filter needs to be a function to return true to keep the element, false otherwise. Okay, return true to keep the element. So X. How can I make this? If X equals, I think if I could just do like this, this condition will always return false, since types number and undefined are untrue, have no overlap. Isn't there like is truthy or something? What is the JavaScript? Check if truthy. Oh, right. You could, yeah, that's smart. No, it's totally useless and only confuses the reader. Values which are translated to true in value also pass the if test because they're value that are valid to true in the Boolean context. They're called truthy. Yes, I know. So just use if value. No, but I want this to be a one-liner. Come on. So I will do it. How's that? And this returns a new array. Okay, so const r equals this. Then we'll change all our args to r. And then it doesn't understand what I'm trying to do. So let's see if I can. Why doesn't it understand? Why? Parentheses here. I'll give you your parentheses. There you go. Type number array, and it's saying, but I'm expecting some undefined. Yes, I know, you dumb. So how's that? Boom. Oh, now what? Object is possibly undefined. No, it's not. Oh, R. There we go. Okay. Let's see. Yeah, we're still getting results here, so. Let's run our tests. And I failed. Can filter on sum. I'm expected 118080, and somehow I'm getting bunch of stuff that is no good. So yeah, there's probably something that I don't understand with what is going on here. What are they expecting us to do here? Here it's a range. Here they're passing undefined in the middle and another thing at the end. So could it be, oh, okay. Like we have to figure out the API. That's kind of annoying. So probably it's from 1 to 100. But they want us to filter out 180. No, that doesn't make sense. What? Mm-hmm. And let's use this one here. Yeah, okay. Now, let's just see what we actually get here. Yeah, I get my 100 and my 180, which was kind of what I was trying to do. So that's not what they want. Let's think about this. They say filter on sum. Filter on sum. What could this mean? I really don't know. I really don't know. That's obviously why they got us to use this, maybe? I don't know. Could it be? Could be. Maybe I need to... But filter what? Like, it's expecting... I have an array of like, I don't know how many results, none of which seem to match what they're expecting, so that's a good start. Okay, let's try something different. What if we were to just... Let's see here. Try to figure out what they're expecting from us. If we were to do 100, what are the numbers we'd be getting back? $62 of them. Including this one here. So do they want us to filter from these only the ones that that's the thing. What is that 184? So I'm taking this to mean the range 1 to 100. And they're making this undefined just to make it, obvious that it's not a range we're looking for. And then the third argument, which I think is a terrible API, but whatever. And then 180 would be what? What am I filtering out? If I'm checking from 1 to 100, what am I filtering? So that's the n, that's the sum. Okay. The ones where the sum does not equal 180, that doesn't make any sense. Or maybe it does. Let's see. If I was to just hard code this thing in there. If okay, so first we make our new triplet. So triplet. Const triplet equals new triplet. Let's just copy this. Okay. Then we check if triplet dot sum is equal to 180. I'm just going to hard code this in there for now. If it's equal to 180, just let's make it not equal. So if it's not equal to 180, go ahead and push it to our little thing. Okay, like that. And what do we get? We get Not to tell what we're looking for. Is it even different? Yeah. We're down to 59 from 60 something, but oh, unless those are the one we're looking for? How many? What was the answer? There's just 3 of them. How many did we have before? So let's turn this around. They are equal to 180. Ah, yeah. There you go. That's what they mean. Okay. Very obvious. Let's just make sure those are the one. Yeah. Oh. Super obvious. Man. Okay. So now we've got so this doesn't work anymore. But now the good thing is we understand the API and we know there's only ever 3. So this would be we're going to call this n because that's what we've been calling it since the beginning. So we need this to be n. Need this to be, for now, let's go back to our 1. And this is just our n. Okay. Let's forget about this for now. Probably going to do this a different way. So now technically, yeah, you know what? I just want to make sure. Can I go back to the good old days where I didn't have none of this stuff? It'll be just easier. Wow, wow. Come on, come on, come on, keep going. Yes, 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 yes. Okay, okay, okay. There we go. Okay. Except that now we're going to have this, which will be, what is it? Range. You know, like if I was designing this API, I would have put the filtering second and the range at the end since it can be undefined. And anyways, I guess it doesn't make a difference. So we're going to call this. We're going to call this range. No. We're going to call this beginning start. We're going to call that start. How's that? Is going to be a number that can also be undefined. It's optional. And we'll do the same thing with the next one, which will be filter. Filter. It's also going to be a number, so there we go. Much better API. Now, what we need to do is if we have, oh, battery's dying out on my headset. There we go. Now, if there's a start, what do we do? If there is a start, n stays the same, so that's cool. But now A becomes start. Right, so maybe there's a way to write this differently. And we'll just do const. No, we could probably just do that right in there. Let A equals 1. No, let A equals start or 1. How's that? Huh? That's good. And let B equals A. Don't need to change anything about that. Now if we have a filter, quite simply, we can do well, we could filter it after the fact. Why don't we do that? Return triplets dot filter, and then triplet is if triplet is equal to filter, then give it to me. Otherwise, I don't want to. Yep. Why? Because it might be undefined. Yes. Crap. So. Well, for starters, it's not triplet, it's triplet.sum, right? Get that right. Now, parentheses are required. Oh, wow, so it might work. So it returns the one where it says true. Now, if our filter is undefined, it's going to return false for all of them. Triplet.sum is equal filter. I really don't want to have to check for undefined on this one. Filter. If filter is undefined, then make it what would return true for everything? If it's equal to true, are numbers equal to true? No, they're not. It's a strict equality thing I'm doing, so that doesn't work. If they are sum is equal to no. I don't see a clever way to do this right off the top of my head. The filter, I'm going to triplet the sum is equal to filter. Then when I get undefined, boom, everything is false and everything goes to crap. So I could, I think I don't have a choice, but to do this on a different line, new if filter unless yeah. Well, I mean, I could just do it straight in the filter. Then I do extra work, you know. Yeah, whatever. So if filter, then return triplets, the whole filter thing. Otherwise, just return the triplets. Ugh, gross. But it'll work, pretty sure. Let's test it. Or not. Which one fails? Oh. Phew. They all pass. Looks like that's it. So really, from what I understand, is the sum thing here is just so that it could implement that filter. The product is a convenience for the test to be able to test the results, like the triplets we're getting. Interesting. The introduction section, though, needs to be, I think, a little clearer, unless part of the exercise is for us to figure out what what the API they want us to, what exactly they want us to do. But it doesn't feel like it shouldn't be part of it. All right. So, do we refactor a little bit? Static where, const triplets. It is using a brute force method. We're going through every single number. Then we're getting the square root of a squared plus b squared. And if that is an odd number, then we're good. We know that it fits our thing. So I'm wondering if, hold on, let's check, since we have a little bit of time. For generating. I think this is what's happening here. Euclid's formula is a fundamental for generating Pythagorean triples given an arbitrary pair of integers m and n, with m is bigger than n. So that's what essentially we have here. Let's get back here. We have an integer here that is a, and we're incrementing that integer, every time. So we essentially have a series of, and then we incrementally, I get it. A equals m2 minus 2, b 2m, c2, c equals m2 plus n2. Right, and that's what we're doing here. We're getting our c that way. Every primitive triple arises after the exchange of A and B, if A is even, from a unique pair of coprime. What is that coprime thing? In number theory, two integers A and B are said to be relatively prime, mutually prime, or coprime if the only positive integer factor that divides both of them is 1. Consequently, any prime number that divides one does not divide the other. This is equivalent to their greatest common divisor being 1. Right. So it means you can only The only common, yeah. No, their greatest well, their greatest. So basically their only, right? Common divisor is 1. (14) and 15 are coprime, being commonly divisible only by 1, while 14 and 21 are not coprime because they can be divided by 7. Oh, right, because they've all, okay, so. Right, but what does that do for us? Proof of Euclid's formula. Following variant of Euclid's formula is sometimes more convenient as being more symmetric in M and N. Same parity condition on M and N. If M and N are two odd integers such that M is greater than N, then A equals Mn, B equals C equals M2 plus N2 divided by 2 are 3 integers that form a Pythagorean triple, which is primitive if and only if M and N are coprime. But then you need to check that not easy to grok. Describe this method for generating primitives using triples using a sequence of consecutive odd integers. And the fact that the sum of the first n terms of this sequence is n squared. So if I take the first 4, for instance, the sum of the first 4 would be 4, 9, 16. Well, yeah. 4 squared is 16. So if k is in the nth member of this sequence, then n is equal to k plus 1 divided by 2. Yep. Choose any odd square number k from this sequence. K equals a squared. And let this square be the, wait, what is a in here? There's no mention of a. A from the, okay. And let this square be the nth term of the sequence. Also let b squared be the sum of the previous n minus 1 terms. And let c squared be the sum of all n terms. Then we have established that a blah, 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 and we have generated the primitive triple ABC. This method produces an infinite number of primitive triples, but not all of them. Oh, so we can't use this. Or can we? Example, choose k equals 9 equals 3 squared. Okay, so the root, okay, get it. Equals 8 to the 2, so 3 is our a. This odd square number is the 5th term of the sequence because 5 equals n, and a squared plus 1 divided by 2, a squared, so 3, that's 9, plus 1, that's 10, divided by 2, yeah? The sum of the previous 4 terms is b squared, and the sum of, no, this would be way too complicated to implement. Generalized Fibonacci sequence if oh, that's Fibonacci's method. Okay, Leonardo of Pisa is Fibonacci's. Ah, okay, Fibonacci. But it's not using the Fibonacci sequence. Got it. This is using the Fibonacci sequence for Fibonacci numbers starting with the and each number being in sum of previous two. One can generate a sequence of Pythagorean triplets. Yeah, but it's not all of them. That's the problem. So I think all of these formulas don't necessarily generate all. Yikes. Height, excess, and enumeration theorem. Pythagorean triples by their height defined as C minus B. Extended this approach, which produces all. Oh, that's interesting. Extended this approach, which produces all Pythagorean triples when K is bigger than H times square root of 2. What? No, what? Divided by D. Write a positive integer H as PQ. Okay. I think my head is spinning. So I think we're going to stick with that. And it's good. I don't like this here. I wish the rest, there's really not much that you can refactor. Let's get rid of these. So is there another way to do this? That's my filtering function here. Is there a way to return true if the filter is undefined? Just return true. Yeah, I could, let's see. Let's think about this for a sec. Hold on. Let's just comment that out and use this here. With that, whoops. We could make this a ternary maybe? Inside of this? What would that look like? So filter. There is a filter, then, you know, is it equal to filter? If there is no filter, is it equal to, well, it's the same thing as using the OR. There's no difference there. And if I see, if I go 15 is equal to true, I'm going to get a big fat false. It's not even loosely equal to true. But we had figured that this is the way to get true. So that works. There's our answer. So triple dot sum equals filter, or if there is no filter, then just return. No, that doesn't work. Yeah, okay. There you go, that's what we need. Convoluted thing. So their filter, great, use the filter. Otherwise, use this triplet dot sum. Then it'll return true. It's not the most yeah, it's not the most readable, and also not the most optimized code, because at least this way I wasn't filtering through the array if I didn't need to. And this way I do. So let's go back to what we had. Null checks for the win. So that's going to be it. That's what I'm going with. Running out of time anyways. So shutting down Quokka. Just going to run the tests again, make sure I didn't screw up anything. Looks good. Going to push that to git solve Pythagorean triplet. There we go. Like that. And now just upload it to exorcism. So exorcism, what is it? Submit Pythagorean triplet.ts. All right, let's just make sure that it was uploaded properly. There we go. A beautiful solution. Yay! All right. And we're done for today. So thanks for sticking around, watching me fumble through this triangle math stuff. And I will see you, hopefully, tomorrow. Well, I won't see you, but you'll see me. All right. Take care, guys.